So basically what I want to do tonight is run it back on what we did yesterday. So yesterday we couldn't get the PID working. Today I found out the reason why. Well, I didn't find it out. Someone who follows me found it out and let me know. So tonight we actually are going to do some PID stuff. We found the solution as to why this wasn't working yesterday. So what I've done, obviously we've got factory IO running. Not that view, this view. Yeah, so we've got it running. I've also got TIA portal in the background with the Siemens program. Let me zoom that in a little bit so you can see a bit better. Looks alright. This is the program we made last night. So last night, after like 2 hours of trying to get the PID to work, we gave up on it in the end. But there's a reason why it didn't work. And the reason is PLC sim. So, in fact, while we're talking about that, let me run PLC sim. Because I haven't got it running yet. Yeah, it wouldn't work. And there seems to be some sort of bug with TIA portal. So, one of the followers, Paxir Electric, I think he's called. Paxir. I'm not sure if I'm pronouncing that right. But he found out the reason why, and he let me know. So I really appreciate that. So let's run up the sim. Connect. How's everyone doing tonight? Let's load. Start module. Oh, Paxir Electric, you're here. I hope I'm pronouncing your name right, by the way, buddy. Matt Gas, was that? I've missed it. What is it? Sorry. Let me find it. Let me find it. Oh, that is how you pronounce it. That's good. That's good. Oh, there's been a few. Appreciate that, by the way. Appreciate that. Yeah, so Paxir, he found the solution to why it wasn't working last night. So last night we just ended up doing some rough control just to get it working, just to kind of put a pin in it. But tonight we're going to bin this off and we're going to actually do a PID this time. And I have tested it, so I know it does work. There's a few things we've got to change in here though. So we're not going to need that. We're not going to need that. We're probably going to change this. I want to scale it properly. And we'll probably change this as well. We can leave them lights as they are.
Thanks for the follow.
Appreciate that, MGK. Thank you. I don't know why I heard that twice there though. Yeah, we're still working on the overlays and stuff. That's still ongoing. I don't really know what I'm doing with it all, I'll be honest. Appreciate all the likes, guys. Thank you. If you get top 3 likes, you'll end up on that scoreboard up there. Right, so this here, we're going to leave that. We're just going to have a constant discharge. So on the sim, there's this drain hole down here. There's a valve on that drain hole to basically plug it or unplug it. We're just going to leave it 30% open. So it's constantly draining. Same as what we did last night, no different. But tonight we're going to get the PID working. So we obviously didn't do that yesterday, and it's, yeah, it was a bit of a thorn in my side. Appreciate that, Michael. Is that Katie? Is that like echoing for you? I feel like I'm hearing that twice.
Thanks for the follow.
Vladislav, thank you, mate. I really appreciate that. Yeah, so let's go then. Let's get started. We've binned off all the stuff we did last night. We're going to change this. What I want to do, let's get a little bit of organisation behind us. And we'll do another program cycle block. And we'll kind of separate the scaling. We've got some scaling to do. Yeah, it's a bit echoey. Ah, why is it like that? Not sure. Anyway, we're just gonna leave it echoing because I don't know how to fix it. All right. So we've got a new. We'll change this name. Antur, thank you. Appreciate that, mate. We're gonna call this scaling. We'll just keep all that separate. So that's OB123. You guys can't see that. Yeah, I can't show you it either. Right, so just take my word for it. This is a new OB123. And we're going to do some scaling now. So there is a block for this conversion. We want to do a norm X. And we want to do a scale X. And we want to zoom in a little bit so you can see a bit better. So the norm X is going to basically normalize it. The scale X is going to then scale it. That's what these two blocks do. We're going to start off with... What shall we start off with? What tags have I got? These tags. We've got the level meter. That goes 0 to 10. We want to make that 0 to 300. We want to scale that so that we're getting an actual readout from the level of the tank. So at the minute it's just 0 to 10. Just think of it as a 0 to 10 volt analog input. Right. And it's a real. We're going to keep it as a real. The minimum is going to be 0. Ansi, appreciate that. I really want to sort that echo out because that's going to wind me up. Wonder if it's that. We'll see if it goes away now. Right, so 0 to 10. I think that's what it is.
Thanks for the follow.
No, it's still echoing. I do apologise for that. Wonder if I can do something about that.
Thanks for the follow.
We'll see if that makes it any better. Appreciate the follows, by the way. Thank you, William. Auntie, I said that, and then the one that I can't pronounce because it's loads of characters. Okay, so the value of this is going to be our level, it was called, or something. Level meter. Then we're going to make a new data block. Let's keep the scaling of the data blocks separate. We'll just call this scaled data or something. That'll do. We want a new, so this is going to be normalized level. This wants to be a real. Yeah, there we go. And we want a scaled level. And that's also going to be a real. What else do we want? What else do we want? The engineer, good evening, mate. How are you, Kyle? What else do we want? We want to scale some more stuff. We want to scale our set point. So we want a normalized set point. Let's try and get some organization this time. Because it's the last few nights has been wild. Scaled set point. We're going to want a normalized PID output. Normalized PID output. I'll just call it output, yeah. And then we want a scaled PID output.
Thanks for the follow.
Gyro, I think. Appreciate that, buddy. Thank you for the follow, mate. Welcome in, everyone. Welcome in. So for anyone who missed it, I did give a little bit of an intro, but tonight we're gonna run back what we did last night. If anyone was here last night, we couldn't get this PID working. Paxir Electric has let me know the reason why. I've since tried it. I got it working. It's a little bit of a bug in PLC Sim. So tonight we're gonna undo what we did last night. I'm gonna actually do some PID control tonight. I appreciate everyone who's following, by the way. Thank you for that. Okay, so scale PID output, set point. the level, which is basically our feedback for the PID. So we've got these two readouts down here. They're just saying 0 to 10. There's like no resolution behind them. We maybe want to do something about that. We'll get to that. We'll get to that. I'll come back to that. For now, let's just focus on the PID itself and the scaling of it. So level meter wants to become, it's not user memory, what have I called this block? Scale data. And this wants to be normalized level. So that's basically going to take our 0 to 10 and change it to a 0 to 1, but like quite high resolution. Then we're going to put this to 0 to 300. I need to put them as reals. You guys can see that, okay? No, I need to zoom out a little bit. No one told me that. There we go. You should be able to see all that now. The PID block will scale ins and outs if you use the per. Yeah, I have seen the per. What does the per stand for? Is that percent? I did see that, but I didn't use it earlier when I tested, so I thought I won't bother this time. Let's try and have no errors tonight. I know how to make it work. Oh, peripheral. Oh, okay. So I'll manually do it. Is this for industrial applications? Yeah, the application would be the filling of a fuel tank, the filling of I don't know, a beer tank, the filling of a toothpaste tank. It could be anything. This is just a tank we're going to maintain the level of. It has a constant output, like a constant drain on it. The ins and outs are normally 0 to 27648. You mean the analog inputs and outputs? Is that what you mean, Ash? Yeah,
Thanks for the follow.
we're gonna the tank has a constant drain on it, but we're gonna maintain how much we feed into it so that we can always maintain like halfway. Yeah, I'm sort of vaguely aware of that, but in this factory I/O, the analog inputs from everything are 0 to 10. This software is called Factory I/O for anyone who wants to know that. Inglay, thank you to follow. HDMI, thank you to follow. John Clare, thank you to follow. Is that everyone? Hopefully I've not missed any. User 801, thank you for the share, by the way. Appreciate that. Right, okay, so does it have HVAC applications? Not sure about that, mate. It has a bunch of predefined scenes. The scene we're working on right now is level control. There is another level control, but that's for like using timers. Similar, I guess, to how we did it yesterday. But this one's mainly for the PID. It's got analog inputs and stuff. I don't really think it's made for HVAC, and I'm not sure how many like you can build your own scenes. You know, there's loads of parts. I wonder if I can pull this over. Not easily.
Thanks for the follow.
There's loads of parts, so you can build up your own scenes. You can make your own factories almost. It's more like factory automation. That's kind of what it's designed for. Right. Let's maximize that. Okay, so yeah, that gives you an idea of what we're doing. So this one wants to be normalized value, scale data, normalized level. There we go. And we're going to put that into scale data, normalized scaled level. So this value in this box is going to be, you can't see it again, hang on. Can you see that a bit better? I've obviously messed around since last night and I've got the view not quite right. Right, I think you can see all that now. So this scaled level variable, that's going to hold the value of 0 to 300 now, which ties up with the scaling of the actual tank, which I'm assuming is like, I don't know, 300 centimeters or something, or 300 inches. I don't know what the actual scale is, but yeah, that's the height, I guess. The height of the... Oh, it's centimeters. It's centimeters, yeah. So it's a 3-meter tank. Okay, so... We've scaled that. Appreciate all these follows, by the way. Thank you. Gabrielle, Lars, thank you for the share, buddy. Really appreciate that. David Littlewood, Cobra, Oheen, I think, and Zeraquel, I think. Thank you for sharing. I really appreciate that. Yeah, it's centimeters. Yeah. I'd call that set point value. This isn't the set point, mate. No, this is the feedback from the level meter. So let me just copy that so we don't have to do it all over again. And bin that one off. So let's call that one scaling of the level meter. We're going to call this feedback for PID. This one's going to be scaling of the set point for PID. We want to change that so it's not level meter anymore. It's, excuse me, set point, which is also 0 to 10. That becomes set point. That becomes set point, and that becomes scaled set point. That probably doesn't actually want to be 0 to 300. No, we'll leave it. We'll keep all the variables for the PID the same scale. Yeah, appreciate everyone who's liking, sharing, following, all that good stuff. Really appreciate it, guys. I'm on this field, but it's boring. You don't enjoy industrial automation, no? Ram, thank you to follow. PF, thank you to follow. Roll, thank you to follow. Really appreciate it, guys. Right, so feedback, set point, and I'll also scale the output. The output, though, what did I do earlier? Did I do it as 0 to 300? I didn't. I did it as a percentage. I did it all 0 to 100. Maybe I should do that again. Yeah, I'm going to do that again just because I feel like I did that earlier. I kept it as a percentage of the tank rather than like the centimeters. We can always rescale again and get centimeters for the readouts, but I'll keep it as 100 just as a percentage. It kind of makes it a bit of like a mockery. All I'm doing is timesing by 10 really, and I'm doing all this, but this is the kind of the way that you scale from as far as I'm aware in Tier Portal. So let me copy that, paste that. So this one's going to be scaling of the PID output. This one won't be 0 to 100 because the actual PID gives out 0 to 100%. Or the way I'm going to do it is anyway. This is the output from the PID. Scaling of the PID output. I guess it's a little bit obvious what I'm doing there, but I don't have it yet, so let me just take that out for now. This is going to be 0 to 100. We're going to make it 0 to 10 because that's what the fill valve requires. It requires a 0 to 10 signal. We're going to call that one normalized PID output, normalized PID output, and scaled PID output. Not set point. There we go. We'll leave that blank for now because I haven't added the actual PID yet, so I don't have. I just don't have it yet. So let's add a new block. So what I want to do is, for the PID, that wants its own OB and it wants a cyclic interrupt. And earlier I had to set that to 200 milliseconds because I was getting errors at 100. Okay, so we've got a nice new block. This is going to run every 200 milliseconds. It's going to run. Over on the right, I don't know if you guys can see that. Let me pull it across. We have some blocks. And one of them under technology is PID control. So I can open that up. The problem I have, or the problem we came into last night, so we're using the compact PID. That's what we're going to use. just because I think that's the easiest one. I'm not entirely sure what the others do. Yeah, I'm not sure. The problem is, this says V6 here. We were using... Oh, you can't see it. Let me pull it across a little bit more. We're using version 6. That's the latest version of the compact PID. That does not work with PLC sim at the minute, or at least it doesn't appear to. So what you need to do, and what we didn't do last night, I would have never known this. I'm not like a tier expert or anything. You know, I'm only just kind of learning this stuff. Apparently version 5 doesn't work. I don't think version 4 works either, or at least the one I was told by Paxir Electric was 3 works, and I have tested this. So I'm going to use version 3, and that takes the actual block itself to version 1.2. So if I put that back to, in fact, there is a version 8. Maybe version 8 works. I don't know. So it defaulted to 6. That's version 2.3 of the block itself. If I go to 3, it definitely works because I've tried it. So let's add that. In fact, before I add that, let me just remove. I've still got the data from last night's one. Let me just bin that out. Pull this. In fact, delete that off as well. Right, pull this in now. It should be called PID Compact 1. That's fine. And I can move that out the way for you so you don't see that anymore. Let's zoom in a little bit. Might be a bit too far. Right, that'll do. So, I can expand this. There's a few more things on the left. There was a lot more yesterday. So on the version 6, there's a lot more inputs you can give this PID. We don't need to worry about any of these extra ones. We can close that. All we care about is these 2 on the left and this 1 on the right. The only way I could do that was if you had a little more work, and I would be happy with it. I'm not sure you're about there, buddy. At least you can change your version. My tier stopped letting me change mine. Did it really? I wonder why that is. See, I mean, you all tell me tier portal was like the best thing since sliced bread, but I'm not so sure, you know. Appreciate Promise for sharing the live. Thank you for that. Myong, thank you for following. LOL, thank you for following. Have I missed any more? Ram, thank you for following. I don't know if I said that earlier. It is. I mean, yeah. I feel like I shouldn't have come into a bug so soon in my journey of tier portal, but 100% is. Nah, GX works 3, mate. GX works 3. Right, okay, so the set point is going to be scaled data. Scaled set point. That's what we're going to give there. The input, which is the feedback, is going to be called scaled data. So these are the ones we've just set up. Scaled level.
Thanks for the follow.
Appreciate the follows, guys. Streetbox, thank you to follow. Baylint, I think. Thank you for the follow. I hope I said your name right. And the output is going to be scaled data dot scaled PID output. That's all we need to do. Well, it's not all we need to do because we need to set it up as well. It just likes a little cuddle kiss down. We're going to leave it as percentage. There is one for volume, but I'm not worried about that. We're just going to go in percentages for now. I don't know why I just unticked that. The input is not input per. So what it's saying here is, what are you using, input, or are you using input per, which is peripheral, I've just been told. Excuse me. What we want to do is set that to input, because that's where we've put our scaled feedback into the input one, not the input per. The output is going to be output, not output per. Don't really need to touch any of this. I do want to set that, in fact I do want to set that to 100%. We don't really want to go over 100%, there's no reason to. So we're just going to clamp the output to 100%. It won't go any higher than that. We don't need to touch that. Warnings, I mean we can set warnings, but I don't really feel like we need to. We don't need to touch anything. It's going to be 0 to 100%. So here is where we're going to set up the PID parameters, the proportional, the integral, and the derivative. We don't need to do, I don't think we need to do that here. Thing is, I've already forgotten what I set it up to earlier, and I had it working quite nicely. But we're going to go through that. That's going to be part of the process, is we're going to tune this thing. Appreciate that, Chris. Thank you, mate. Craig, thank you for the share, buddy. Really appreciate that. Thank you. So, right, we're nearly there now with it. We're almost set up. What else do we want to do? The main's looking good. We don't need to touch anything there. That's a bit too zoomed in for you. That's better. We don't really need to touch anything here. We've already binned off all the stuff that we did last night with the rough analog control. Cyclic interrupts ready to go. The scaling is ready to go. So I think we can maybe download and see it work. I hope I haven't missed anything this time. I'd rather there be no issues tonight. Unlike last night. Shabba, thank you for thank you for the follow, mate. Appreciate that. Let's download. Error. Oh, we have got errors. We're already starting with errors. What's wrong? Let me pull up the. Ah, it's because there we go. I didn't put the output. So this is. Oh, hang on a minute, hang on. I've just realised I put the wrong thing. We don't want scaled data here. Scaled data is going to be scaled by this. So I'm going to create one more. Let's put this in user memory. And we're just going to create one called PID output. That's going to be a real. It's easier if I just type it. So the actual PID output is not that, but it's going to be user memory dot PID output. So then in the scaling block, we're going to use that as the input to the scaling. So that's user memory dot PID output. Let me bring all that down. You don't need to see all that now. That should compile okay now. No. Block user memory that is accessed has not been compiled. Ah, sorry. Right, let me compile that. Let me compile that. I'll compile these as well. I thought that button was supposed to compile everything. Obviously not. Let's do a full compile now. Right, we're good. We're no errors now. Appreciate the follows, guys. Sanders, thank you for the follow. Alejandro, thank you for the follow. Lair, I think, thank you for the follow. Appreciate that. Let's download now. Kevin, thank you for the follow as well.
Thanks for the follow.
No. Oh yeah, we want to stop all. We stop it. Seb, thank you for the follow. Appreciate it, guys. Right, finish that. We should be good to go. No, we shouldn't be good to go. There's one thing I forgot. This is going to run all the time. I don't want it to run all the time. I only want it to run when my process is running. I do have a bit from this that we made last night. So we have process run. That's going to enable it. Just to show you what process run is. Basically, we've got a start button on the control panel. We've got a stop button. We have the process run bit. When we press the start button, it's basically just going to latch in. And process run's going to keep running until we press the stop button. The stop button is physically a normally closed contact. So we have to use a normally open contact in the ladder. This is, as I said, so I maybe should comment some of this stuff. So this is the control start stop.
Thanks for the follow.
This is our constant tank drain. So like I said earlier, the drain is going to drain the tank with the valve being 30% open. Which country am I from? I'm from the UK, mate. How should I start learning PLC programming? I've got a whole video on that that I made a couple of weeks ago. called Low Cost Methods for PLC Programming or something like that. Have a look at that, Robert. I put
follow.
all the information that I could tell you now, but there's like visuals to go with it.
Thanks for the follow.
Random Citizen, thank you to follow. Craig Bruce, thank you for sharing the live again, mate. I really appreciate that. Yon, thank you for the follow. Shefandes, I hope I've not crucified your name there, but thank you. PYM, thank you to follow. Okay, so yeah, that's the constant tank drain. Just to remind you,
thanks for the follow.
The tank has like a drain hole. It has a valve attached to that. So if that valve is fully closed, nothing drains out. We're going to leave that valve 30% open. So we've got a constant drain because the PID is no good unless there's some sort of force acting on the system. So we're just going to have a constant drain. So we're going to be able to maintain like 50%, 60%, whatever we set the set point to. Okay, so this bit here was just basically for the panel start lamp. This is for the panel stop lamp. The panel stop lamp in Factory IO is totally rubbish. It's a black lamp. You can basically never see it come on, or it's very difficult to see. This white one will get a bit brighter. Guys, appreciate the shares. Janitor Tech, welcome back, mate. I don't know if you've been here since the start, but we're basically running back what we did last night, but getting it working this time. Trey and Auto, thank you to follow, buddy. Okay, so just to give some comments to this logic that we've done. What was this? This was basically, we're going to change this, but I'll comment it anyway. This is for the the SP meter readout on door. I'll show you what they are for. What was this one? PV meter readout on door. We'll change this because I never really liked the way I did this yesterday anyway. So we've got 2 meters on the door, SP, PV. SP is obviously the set point, so this will give us a digital readout of what the set point is set to. The PV is the actual level that the tank is. So for now, we'll leave them as they are, but we are going to change them. It's a bit of a minor thing. It's just more scaling, really. Did I make this simulator? No, I didn't, mate. This is a big company made this. I think they're called Real Games or something. I think Factory IO started off life with the intention of being a game, and then they realised they could make an absolute shed load of money by selling it to industry. It's not free, buddy. No, it's not free. It's you can buy it on a subscription, so you can pay a monthly fee of £28, which or is it euros or something, which isn't cheap. Or you can buy it outright for like 700-ish. This is called Factory IO. So it's a simulation tool for industrial automation. Do I have a video? No, so EN Squared, what you'll need to do is have a look on the website for Factory IO. They give you a template program. So this is a template program, and as part of that program, they have a function, FC, if I show it in the main, right at the top, FC9000, they put this in, which has a load of structured text in it, which does something to make the communications work. I'm not entirely sure of what all this is, but you need that in order to get the comms to work. The easiest way to do it is just download their template program. Okay, so what was I going to say then? Yeah, PV, the readouts on the door, we'll set them up later. Appreciate all these follows, guys. I really appreciate it. Let me just go back and find some. Amigo, thank you for the share, mate. Engineer JM, thank you to follow. Garrett, thank you to follow. Aldar, thank you to follow. Boggozola, I think. Thank you to follow, mate. Really appreciate that. And Hograld, I think that's how you say your name. Thank you for the follow. Really appreciate it. Okay, let's write this, and we'll get going. We'll get tuning. That's the hope, anyway. Yeah, I was pulling my hair out last night trying to get this to work. and it turned out as some sort of bug. So yeah, we're downloaded now, I believe. Let's go into the simulation. If I press the start button, I have to run it first. I press the start button, run this. That didn't do a right lot. Are we running? PLC Sims running. Why is it not running now? Let me just do another download just in case. Load.
Thanks for the
Finish.
follow.
Go live.
Thanks for the follow.
Yeah, that's definitely running.
Thanks for the follow.
I haven't connected it. That's why I'm an idiot. You need to connect it. There's a button up in the top right. You can't quite see it, but it does say connect. Now we're connected. That will make things easier. So I pressed the start button. That little light got a little bit brighter. The panel lights aren't great. So now we should be running. We are. Let's go to our PID.
Thanks for the follow.
And I want to go to the commissioning one actually. So go back. So this is the commissioning screen. I think you can just about see it. Try and put it a little bit better in view. I'll start measuring the PID. The sampling time. It's not happy about that. I think if I start it anyway, it will just do it. Can I change them now? Not at the moment. So
Thanks for the follow.
I've lost it. Where's my commissioning screen gone? Alright, it's at the end. There we go. Can I just start it? Right, I can just start it. Tuning hasn't started yet. I found the tuning not to work very well. The set point's showing 0. Let me check that. Appreciate the follows, guys. I really appreciate it. I've never expected a Tier Portal Factory IO combo on my FYP. Yeah, it's a little bit different, isn't it? It's a little bit different. I appreciate you showing up though. Jepa Minto, thank you to follow. Belajar, thank you to follow. Habakkuk, I think. Electronics, thank you to follow.
Thanks for the follow.
Sam, thank you to follow. Guillermo, thank you to follow. Yasin, thank you to share for the share. Thanks, I really appreciate that. Fabio, thank you to follow. Andre, thank you to follow. Atina, thank you to follow. And Casimir, I think, thank you to follow. Okay, so let's have a look at why my set point is showing 0. It probably is because I haven't showing 0 because it is 0. So my set point is this potentiometer on the door. I want to set that to around 5, which is halfway. We are now seeing 50. We're now seeing an output, so it's kind of running. Might not run very well. Well, it won't run very well because it's not set up yet. But you can see the output is starting to do something now. If I can, there's one of these that let me zoom in on that portion. So you can see we've got a set point of 50%. That's what the set point is. The output is now increasing, increasing. You'll see in... No, you won't see in the... Ah, okay. I found something I've not done. I haven't mapped the PID output to the fill valve yet. Yeah, appreciate that, Katie. If you want to make... If you want to do text to speech so I can hear what you're saying to me, you need to be basically on the leaderboards here or a super fan, and you put a dot before your comment and I'll be able to hear it. Yeah, so the fill valve, we're not opening the fill valve because the PID is running, but we are not giving that value to the fill valve. So let me just fix that real quick. That's my fault. Let's stop that. Where shall we do this? Where's best place? Let's just do it in main. No, in fact, let's do it on scaling. Now that I think about it, we don't need this scaled data.
Yordsky says PLC masters in the making.
Jordsky, welcome back, brother. How are you tonight, mate? We got there. We finally got there. Shout out to Paxir Electric for finding out the reason why it didn't work yesterday, by the way, as well. I can go directly to the fill valve with that one, so I don't necessarily need a value there, like a variable even. So let me download that again. And then we're going to see the tank start to fill. It won't fill very well because we need to tune the PID first. I've missed a few follows. User 772, thank you for the share. Really appreciate that, mate. B Cornell, thank you for the share. RBR, thank you for the follow. And Coro, thank you for the follow. Really appreciate it, guys. Okay, so we should be downloaded now. I definitely downloaded it, didn't I? Yeah, I think so. Right, so the fill valve's coming directly off our scaling now. The temptation to do some shout-outs with her dot. Who are you shouting out? Shout out yourself, mate. I've been trying to share all your stuff. I want you to get some followers and that so you can jump on the live sometime. Did you get sorted with your setup as well, with your Mac? Guys, don't use a Mac to live stream.
Dixon Mays.
Oh, I got done with the Dixon. I also got done with another one, but it was a little bit closer to the edge, that one. I think it was like my second or third live stream. Someone basically said, what was it again? Mo Lester has got a really good YouTube channel, and I was like, oh yeah, Mo Lester's got. Yeah, I shouldn't have said that. Do you also use Studio 5000? I don't, mate. I don't. So let me go back into this. I'll press the start button now. I don't think we were. Let me stop and start again.
Puck Whisper says, couldn't be bothered to sort it tonight.
Ah, fair enough, mate. Yeah, it sounds like a headache. It does sound like a headache. So we need to start the PID. Go back to the commissioning screen. Let's start the measurement from scratch. Start the PID. If we go to this and this, we should start to see that output increasing, and we should start to see some filling, which is what we were struggling with yesterday. The PID was giving no output. Hi, this is my first time. Which PLC is this, and do you organise formal training on it? This is a Siemens S7-1200 PLC. I don't do training, to be fair, buddy, and I'm definitely not qualified for doing any sort of Siemens training because I'm just kind of learning it myself. Appreciate whoever is sending those gifts. Black Lion, thank you. I still haven't sorted out why that keeps repeating either. In fact, it's really annoying. Let me just turn it off a second. It's still going. It's still going. We're just going to have to bear with it. I need to fix these overlays. I need to fix them. Are you working on PLCs for water treatment plants? I do work. I work in power generation, mate. So I do work at water treatment plants. Oh, can't even say it. But it's more on the generator side, on the backup generators and that sort of thing. It didn't do that earlier. Yeah, I don't know why it's doing it now. I need to sort that out. Yeah, I don't do formal training. I do try and help where I can, especially if you're a super fan. I'll try and give you as much time as I possibly can. But yeah, I don't really do training and that sort of thing. So this is still filling. Like I said, this PID isn't really set up at the minute, but you can kind of see how it's starting to work now. So the output has slowly increased. It's been keeping increasing, and as we started to approach the set point, it's trying to back off. It's a little bit slow at the minute. This green line is the actual level of the tank. We want the level of the tank to stop on the black line. The black line's the set point. But the minute it's overshot. Let me just bin off the legend. I can explain. So the red line is the output of the PID. The green line is the tank level. The green line should be going to this black line. That's the idea.
Thanks for the follow.
So it's not maintaining the 50% at the minute. It's set around 50%, the tank level.
Thanks
Which
for
should
the
be
follow.
about 150 millimeters.
Thanks for
You
the
can see we're a little bit high, but it is coming down. However, because it's so slow, there's a good chance it's going to undershoot now. Then it's going to overshoot. Then it's going to undershoot. And we're just going to have this a little bit of an oscillation. Eventually it might settle down. It doesn't look too bad at the minute, to be fair. It might settle down quite early. But yeah, we've got the PID working, which is a massive bonus because yesterday we just couldn't get that done. Disable the call for the tune. You're automating the process of adding peroxide to intensive feed. I mean, that's something I don't really know anything about, to be fair, mate. Like I say, I work in power generation, so all my knowledge and my expertise is around synchronizing generators, automating mains and switchgear, power management, hybrid systems where you've got diesels and hydro and solar and wind turbines and managing all that. That's kind of my expertise, but I can program, and as part of that we do, you know, a reasonable amount of PLC work. So stuff like what you're saying there isn't my expertise. I can maybe help with some of the programming side, like I can help you maybe give some advice on what to do in like how to do certain control and stuff, but the actual process I wouldn't know anything about, mate. Matt Connor, thank you for the follow. Tom, thank you for the follow. So let's just go back to factory IO. It's settling. It's almost maintaining. So don't forget, this tank has a constant drain on it. There's a constantly liquid coming out of here. We do have a flow meter, which I never actually set up yesterday. Pedro, thank you for the swan, mate. I really, really appreciate that. Thank you. Yeah, so there's a constant drain on this. So while it looks like not a lot's happening, we're constantly feeding this tank with fluid while it's constantly being drained, but we're maintaining, or at least we're going to be maintaining, like a perfect 150. Right, so it has settled. It's not bad. To be fair, the default settings are not bad. They're a little bit slow. It took a while. You know, it took like, I think I can put some crosshairs on this. It took from that point to that point. It took like over a minute for it to come down from its overshoot. And how long? So from I've left that from 0 to basically maintained. It was about 5 minutes.
Thanks for the follow.
Tony, appreciate the follow. Thank you, mate. Cryptic Pluto, I think. Yeah, Cryptic Pluto. Thank you for the follow, buddy. I appreciate that. So
Thanks
what we can
for the
do now
follow.
is we can mess with the PID parameters.
Thanks for the follow.
Appreciate the follows, guys. Undo, thank you. Andreas, thank you as well. Appreciate it.
Thanks for the follow.
I'm glad that worked because that was a
Thanks
nightmare
for the
yesterday.
follow.
We're a little bit high, but that's probably the set point actually. So the set point won't perfectly be in the middle. Kind of looks not too bad, but yeah, there's a little bit of error in there. Thomas, thank you for the follow. Zed Wilson, thank you for the follow. Kevin Castro, thank you for the follow. Appreciate it, guys. Okay, so the PID is working. Now is a case of messing around with the values until it works very well. I've already forgotten what my values were earlier, and they worked pretty well. But there's no reason why we can't just have a play around. So the proportional, it's going to be difficult to set this up while it's already kind of halfway. I wonder if we reset the... Yeah, if we reset that, we're no longer at halfway. You see the feedback dropped to 0, so the output shot up. It's coming back down. So let's maybe try. I did have this able to change earlier. Was it this tick box? Yeah, it was the tick box. So I can change these values on the fly. It does give that like Windows noise for whatever reason. I'm not entirely sure why. And we might even make this more unstable. What methods to find the value using Ziegler-Nichols? I'm not. No. All the methods that, you know, all those like known methods, I've totally forgot about all of them. I do remember learning about them, using them, but nah. To be fair, I just I just play with them until I get a feel for it, and then I go from there. Yeah, that's how I tend to do it. Mariano, thank you, mate. I appreciate that. PLC looks complicated. It can be. It definitely can be. PIDs probably are quite, you know, they're reasonably advanced for PLCs. That's what the auto-tune... I'll show you the auto-tune, mate. The auto-tune did not work for me earlier whatsoever. Is it... Let me do it from scratch. I'll just press it. I'll see what it does. It might not even like it. So I tried the auto-tune, but it just weren't having it. No, it won't... It won't do it. There's some errors or something. Let me restart the simulation again. Maybe I need to turn it off first. Oh, but when I yeah, when I tried to tune it earlier, I did get it tuning. I did get it working, but it was rubbish. Is that a PID controller? Yeah. So that's what we're setting up at the minute. It is giving me an error. I'm not sure what the error is for. Let me just upload those. Error starting pre-tuning. The process. Ah, the set point. Is the set point gone back to 0 since I restarted? Probably. Let's set that to 5. Try that again. Right, pre-tuning in progress. It definitely didn't work very well earlier when I did it. Fine-tune will. You probably need to fully parameter use the PID block for the pre-tune to work. Ah, is that why? Possibly. Money. Wrench, thank you, mate. I know you've changed your name. You used to be Pickle. I appreciate that, brother. Thank you for those gifts. It's still going. It's still tuning. Thank you, mate. Thank you. I recognise the photo. That's how I know you used to be called Pickle. You've been in a few of the lives. I'm starting to remember some names and some profile pictures and stuff now. Keep KI 0 and start with KP until it oscillates.
Thanks for the follow.
Well, we're gonna try this tune, this system tuned, but yeah, this is basically looks like what it was doing earlier. It's very choppy. It's very on-off. And in my mind, that's not really what it should be doing. Nah, just temporary on arcade, buddy. Kepasa Jr. JR, thank you for the follow, mate. I really appreciate that. So if we look at the simulation while this is going on, so this is what the pre-tune looks like, which is why I basically didn't use it. It looks at the range and has to be ages away from a set point. Pre-tune just does a rough idea. Is that right? So if I did a fine tune, would that work? Fine tune in progress. Nah, it's not happy. So this is the error I was getting earlier when I tried this. It was basically not happy that the cyclic interrupt was 100 milliseconds. Then I put it to 200 milliseconds, and it's still not happy now. Yeah, I'm not sure. It like I think it must have stopped. It got to 2 bars and then I got the error. Yeah, I don't think it's doing it anymore. So yeah, I'm gonna go for a manual. I think we're just gonna do it by visual, really. Which color is process and which one is CV? So the black line is the set point. The green line is the feedback. That's the PV. And then the red line is the output, which is MV. Is that right? Yeah. The tuning didn't work very well. So let me bring the commissioning screen back. I think that's that one. I think we need a relatively low gain. Let me turn that off. Let me turn that off. Our tank level is continuously dropping. At the minute, I think the PID is actually just faulted out. It's not starting.
Thanks for the follow.
Appreciate the follow. Thank you. No name. Is your name just a space or something? Appreciate that. Thank you. No, this isn't MATLAB, mate. This is Siemens TIA Portal. El Papi, I don't, to be fair, I don't do PIDs enough to know or remember. You'd have to be using them fairly regularly to remember the different methods. I tend to just try and do it by eye, by feel. Seems to have reached its sort of limit there. So if we add in some integral, that's the error over time. So it slowly adds output because the error hasn't changed over time. The longer the error is still there over time, the bigger the output's going to be. So again, just for those who are just joining, the red line is the output.
Thanks for the follow.
Of the PID. The green line is the feedback, so that's the tank. So we are filling a tank right now. So this is the simulated tank that we're filling. It has a constant drain on it. There's like a plug hole in the bottom. Fluid is coming out, and we're replacing that fluid to basically try and maintain around 150. I've got the set point on the control panel door. It's probably a little bit low actually. Hard for me to show it right. That's probably closer to about 150. So we're looking for this tank to stop and maintain around 150, which is, this is in centimeters, so it's 150 centimeters of fluid. And if we go back to the PID, you can see that's where I've just increased that set point. So that's why that line just jumped up a little bit. There is a way to basically just show that portion. Although when I do that, I have to kind of manually move it myself, which I don't like. So let me just stop it and start it again. And if I go to that one and that one, those two. Oh, I appear to have broken it. 1 second. Oh, it's not even those ones, is it? It's that one and that one. That's what I'm looking for. Apologies. So, yeah, red line is the PID output. Green line is the feedback. So what we want to see is the green line basically going to 50 and staying there. Appreciate that, Mrs. Logical Controls. I will be putting this entire live stream on YouTube tomorrow, and I will also be putting the files that I'm using, so the Siemens TIA Portal file and the Factory IO file in my Discord after I'm done the live stream. So if you want to play along, if you have Factory IO and Siemens TIA Portal, you can get those files off my Discord and have a play for yourself. And if you missed any of this live stream, it will be on YouTube tomorrow or the day after. Nielf, I think. Yes, it is, mate. Yeah. You can join my Discord. Yeah. It's the link's in my bio. The link's on there. You'll need to click the top right icon, and if that still doesn't work, then just copy and paste the link into a browser. PID, that's right, mate. Yeah. So that's not too bad. There was only a little bit of overshoot. So we're already fairly close, I would say. The overshoot can maybe be compensated for with a little bit of D or something.
Thanks for the follow.
Liam, thank you for the follow. Luna Glow, thank you for the follow. Appreciate that. So you can see the tank is...
Thanks for the follow.
It's not far off 150, but the set point's not perfect either. So just so you know what the actual set point is. Let me put that into run. Wait, the set point isn't quite 50. This is a percentage of the tank. So we're just slightly under 50%. So that's why we're just slightly under 150. Because the max range of the tank is 300 centimeters. So yeah, we're slightly under, but that's not too bad. That is not too bad. As a PID, it's not very quick though. So maybe we can play with it a little bit more. I am running out of time though. This is a short stream tonight. Just kind of, the main idea was to kind of just get back to what we did last night. Clear the reason why it didn't work, because there was a lot of people in last night trying to get the PID to work, and it turns out it was nothing that we were doing. It was just some sort of bug that exists in PLC Sim. Razim Tech, thank you to follow, appreciate that. Jonathan, thank you to follow as well. So this software here is Siemens TIA Portal. This software here is Factory IO, which is a simulation software. So what I'm doing is I've got TIA Portal talking to Factory IO. So my software, my PLC programming software, is getting values from Factory IO and giving values to Factory IO in order to run the simulation. That is absolutely spot on. You see the green line is sitting right over the black line now. There was, like I said, there was a little bit of overshoot, a tiny little bit of undershoot, but in general, that was, you know, that's reasonably set up. We're not even using NED. This is just a PI controller at the minute. PID in the interrupt program, OB30. It is, mate, yes. You probably can't see that. In fact, I can't even show you that unless I move the whole of TIA Portal across. So that is where the PID exists in OB30. We have a main which is doing some other stuff. I created this scaling one just for the scaling that I needed to do. Yeah. Which TIA Portal version is it? So this is version 20, but one thing you do need to know is this PID compact block that I've used is version 1.2. I think the current one is something like 2.3 or something. That doesn't work with PLC Sim, so you have to use 1.2. There is always overshoot or undershoot. You can program that out. You can make it so your ramp is perfect. You know, it just takes a bit of fiddling around, a bit of messing around. But in fairness, for what we're doing, this tank, the overshoot probably took it to like 155, 160 or something, but then it came back down and it's maintaining perfectly. There's no wobble or anything, you know, it's perfectly solid. So now in real life you can get it so there's no overshoot. You just need to set up your parameters right. Because you don't have to make it as you know, fast acting. You can make it much slower acting, and it'll just slowly creep up. Lethando, thank you for the follow. Eng Ocean Hill, I think that's what that says. Appreciate that, thank you. Chuck, also thank you for the follow. I've missed some, haven't I? Lireshen, thank you for the follow. George, thank you for the follow. JM, thank you for the follow. And Razim Tech, I think I already said that. Yeah. Hopefully that's useful to some people, especially if you were in the live last night when we just could not get that PID to work. We ended up doing some. Well, I put the video on earlier, like a highlights clip of it. Where we used like basically analog control, and it just maintained between 45 and 55%. It was just on at 45 till it got up to 55, then it was off, then it drained, and it was just kind of jumping between 45 and 55. But now we've got perfect control and it's just sitting there maintaining. Obviously in the simulation it's not quite right. If this was real, you'd have splashes and stuff, you know, ripples in the liquid and the fluid and stuff. The simulation only really shows that if you're on off. Yeah, no, it's And well, just shout out once again. I don't know if he's still in here, but Paxir Electric, PAXCIR.electric. He was the one who discovered why we couldn't get the PID working. Because I think he basically what he said was he's doing this for real or something as part of work. You know, he's doing something very similar. And the day before yesterday, he was struggling with this, and he found the answer. And the answer was basically to use. Let's go back to it. I want instructions to use version 3 of the PID compact. So I was using version 6. That's what it defaulted to. I don't know Tia Portal that well, so I didn't even know you could change versions. But version 6 does not work with PLC Sim. It'll work in a proper controller, you know, an actual hardware. But PLC Sim doesn't like version 6. You have to go to version 3.
Thanks for the follow.
And that's why it wouldn't work last night. Appreciate the follow, Thin H. Thank you. And Leo PL. Appreciate that. Thank you, buddy. Yeah. So that's PID control. I can change the set point now. Let's actually see, because although it's steady state is great, how does it change with changes in the set point? Unfortunately, the graph isn't showing 0. So that I might just start it again. Let me just start it again, because it's very slow. Oh, in fact, no. Let me stop it, because what I want is the graph to show 0, and it was showing 30. And there probably is a way to sort that out, but I don't know enough about it to sort it out like that. So let me stop that. Let me start that again. Let me start the simulation. Let me set the set point to 7, so 70%.
Thanks for the follow.
Is that showing 0 now? I think, yeah, that's 0. Is it? Zoom out, zoom out, zoom out, zoom out. Oh, that's zooming in. My bad. I'm confused by the graph here. The scale's set to red for some reason. How do I change that? Ah, that's better, that's better. There's 0. So what we're hoping to basically see is this green line should just go to this black line. Like I say, there's a bit of overshoot. There's a tiny little bit of undershoot. But what I wanted to see was the graph at 0. And then we can start changing the set point, and we can see how it behaves according to, like, well, changes in the set point. Rodrigo, thank you for the follow. Appreciate that. You can use PLCM Advanced where the new appear. Yes, that's right, Michael. I did see that as well, actually. And I do have PLC Sim Advanced, so I could do that. I'm very new to Tia Portal, so I don't want to do anything too crazy. I'm trying to slowly build up my knowledge of Tia Portal. I haven't got to PLC Sim Advanced yet. I haven't gone down that route. Let me get the basics down. I'll try and get the S7 1200 figured out before I work my way up to 1500s. Okay, so we're steady state now. It is a little bit slow. It took a little while, but it's a big tank. It's a 3-meter high tank. So let's. I did say I was going to change the readouts so they read accurately, but I'm kind of running out of time. I haven't really got time for that. So let's set it to 20%. We should see it start to drain. And if anyone's got a calculator in front of them or are good at maths, what is 20% of 300? In fact, I can tell you that's 60. You don't need a calculator. Put your calculator away. What do you need to do? What do you need that out for? Yeah, we should around 60ish. We should. Oh, George, you're going. Thank you for coming back again, mate. You're 34. You need 8 hours sleep. I am 33 very soon, and I need my 8 hours sleep too. So that's why we're gonna end up finishing up in a second. Appreciate you coming through, though, mate. Thank you. Right, so it's just coming down. It's coming down. Can have a quick look at the graph. The green one is the feedback. The actual output is set to 0 at the moment. So the valve up the top is completely closed. That's completely closed. We're not filling whatsoever. You can see there's no stream. But as we get closer to 60, it should start opening up again. And there we go. I can see a little stream now. And that's going to get bigger and bigger and bigger as we get closer. And let's look at the graph. There's going to be a bit of undershoot, I imagine. But you can see it slowed right down. And then it will start to go up a little bit more again. Good luck, mate. Been doing automation for 6 years now. 6 years now as a full-time job. It's fun. Nice, mate. Yeah. I don't really work with factory automation, but I do work automating power systems and stuff like that. So yeah, I enjoy it. This is the sort of thing I like and love, sort of thing. Got a passion for it. Us old people, you're right, Jodski, we are getting on. Although you're 91, I'm 93, so you're even older than me, mate. Yeah, there we go. It works well. The PID works pretty well. I'm quite happy with that. I help run a company that makes HMI and PLC here in the States. Nice too. Yeah. Babies. Yeah. How old are you, Ash? Out of interest. Jamie, thank you for the follow. Appreciate that. Is this a video game? It's not a video game, mate. No, it's a simulation software for industrial automation. Yeah, so I'd say that was a bit of a success. I was quite happy with that. When I tested it earlier, it worked pretty much the way it does now. Next one starts with 4. Really? Wow. Getting on, mate. Getting on. Well, happy birthday for when it comes. But it just means you've got a lot of experience. So there's the benefit to it. You're not as young and dumb as you used to be. Oh, you work with high-speed motion now instead of process automation. Oh, okay, cool. I've never done any motion control. Never done any of it whatsoever. So that's all totally new to me. Yeah. Right, I'm going to wrap it up. I'm going to wrap things up there, guys. Hopefully that helps someone. If anyone missed, the live where we went through all this, I'll put it on YouTube in full tomorrow. If you want to get hold of the files that I've got, I'll save them. The TO Portal file and the Factory.io file. I'll put them in my Discord so you can download those and play along. Yeah, it was last night was a bit of a nightmare, but I'm glad we've sort of resolved this. I can close it out now. Appreciate that, Ash. Appreciate that. So yeah, won't be on now probably till the back end of next week, either the weekend or maybe Thursday. We'll see. Mind, thank you for the follow. Appreciate that. Would you recommend the S7 for a beginner? I imagine it's probably not bad to begin with. In fact, that's kind of one of the first PLCs I used was an S7 1200. And yeah, they're all right. They're not bad. I just never continued with it. I moved on to Mitsubishi and Schneider, and never really picked it up again until about 3-4 weeks ago. So I'll put TSM. If you join my Discord, I'll put them all in my Discord. There's a group, like, I don't know what they're called, a Discord channel called PLCs. I tend to drop them in there. Yon, thank you for the follow, appreciate that. And you can find the link to my Discord in my bio, mate. So yeah, the files will be there. CodeSys is free but can't connect with Factory.io. CodeSys can run on Raspberry Pi for cheap. You're right, Michael. Before I had kind of the money to get PLCs and stuff, that was the very first thing I ever did, was put CodeSys on a Raspberry Pi. I have a full video on it, on cheap ways to do this. Nowadays you can use something called OpenPLC, and you can run that on an Arduino, which is pretty cool. Tomislav, thank you for the follow, appreciate that. Yon, thank you for the follow. Good, yeah, TSM, join it, and I'll put the files in shortly. Yeah, so the Factory.io, I guess CodeSys, I'm assuming CodeSys will have Modbus TCP, maybe even OPC UA, and Factory.io has all these drivers. So I'm using this one at the minute. We're using PLC Sim because I don't have a physical Siemens PLC in front of me. I do have one, I just haven't bothered using it because it's easier to use PLC Sim. But you can use Modbus TCP and you can also use OPC. So I believe CodeSys will have either one or both of those. So yeah, you maybe can work with CodeSys, use CodeSys to run this. But I think CodeSys has a limited runtime, so you might have to restart it every so often. Yeah. OpenPLC, yeah. I've got a video on it I did a few weeks back. It's interesting. I only recently discovered it. I didn't know anything about it either, but it's pretty good. Yeah, no, it does all 5 IEC 61133 or whatever the number is. All 5 PLC programming languages anyway. You can run those on an Arduino. 1 hour license, yeah. CodeSys have nailed it. CodeSys have really nailed it because they've made the software free. They give you a 1 hour license runtime, which you don't need any more than that when you just want to practice and play around with stuff. You know, that's a good amount. 1 hour, 2 hour, that's perfectly fine. It basically stops you from using it in an actual industrial setting. You know, no one's gonna want you putting in a PLC or something into their, site, and they have to go out and reset it every 2 hours or 1 hour. You're working in factory maintenance, only done some Molar easy programming. Oh, okay, yeah, the Eaton ones now, easy, is it Easy 5 or something like that? I've never used them, but they look alright. Beckhoff, yeah, Beckhoff's definitely quite a popular brand. I've never touched them though, to be fair. I had a 1-day training session and don't remember any of it, to be fair, yeah. Anyway, I'm going to jump off now. I appreciate everyone for showing up. Thank you again, and I'll see you some point at the end of the week, maybe the weekend, when I live stream again. Appreciate everyone for coming. Thank you.